about with the multiplication. Once we had some visitors at the school, and they wanted to see how we worked with children with problems. And I wanted to show them the concept teaching model, but I thought I'm not going to use this girl just to show them. We must find something to work on that would be relevant for her. And we worked a little bit on fractions, not to make her able to calculate with fractions actually, but because fraction is helpful when learning decimal numbers, and decimal numbers can be useful in some certain ways. And at that time, not anymore in Norway, but at that time it was relevant because the receipt you get in the shop would typically have a decimal number as the sum of the amount of money you need to pay. So it made sense in a way to work on this with her. So we worked on halves and fourth parts, and we worked with the concepts in the ways that we've done here, and or indicated actually here, and also calculated and related to them in different ways. And of course, when decimal numbers is the point of it, and what makes this whole process makes it make sense, then it's necessary to arrive at the 10th parts, which is much more complicated than the halves and the four parts, of course. So I was thinking a little bit, considering how can we do that in a way that's helpful for her. So I decided to just try, and we had in these small books, math books with squares, those small, actually round, so about one square centimeter, and I cut out 10 of them, and I cut one of them off. Here is something making it not looking like it should. I'll correct that later, but I ask you to image that this one looks like the others. This one look like a square, and this is hidden. This is not there anymore. So we cut it off, and we sat there with the 9 and the 1. And I asked, look here, what could we call this small one? What kind of part could we call it? And she looked at me with a question in her eyes, and she said, pen pot? Mm-hmm. And actually, that was, again, a sign of transfer that was totally unexpected to me. I didn't really expect her to be able to do that type of transfer. And it was really, you learn a lot as a teacher, you can say. Mm-hmm. So, and that is a good starting point for working with decimal numbers, to know what the 10th part is. And when you know what the 10th part is, it's not that difficult to also recognize the 100 parts. So, let me again. And the curriculum says percentage, fractions, and decimal numbers as one in one frame, indicating similarities between them. Am I right? I have to look here to just yes. It's just on one line as well. It says fractions, comma, percentages, comma, decimals. Mm. So that makes it relevant to ask these questions. How are these similar? And it is so kind of self-explaining, maybe. It should be, and it should be obvious to anybody. Actually, I don't think that any teacher in all my school years, and I also had a lot of math in the upper secondary school, And never I heard somebody speaking about these similarities. And I think they should have. I shouldn't have needed to be a grown-up teacher until these similarities really dawned for me as a light. Because it is so helpful when you switch from one to the other of these ways of noting it, because that's the only difference actually, that we use different words and we write it in different ways, but it's totally same, all these. And not least knowing about the decimal number. This is not the number behind the company, yes it is, but that's not the point of it. The point of it is the symbol of 1/10 of a whole of something. And the really genius, how do you pronounce that in English actually? But the really big issue here is that it is so simple, and it relates to anything that could be divided in 10 equal parts, whatever it is. And again, back to this concrete materials, and let's now the decimeter stick, forget about it being a 10, and we can decide what it is. Of course, the children have to learn that as a part of flexibility, and some of the ADHD children who are maybe not so flexible will maybe protest a little bit, and then we need to make it reasonable for them by demonstrating, and actually by having them understand that this is some aid that we use, and we can decide what they're going to help us with. And when we want this decimeter stick, excuse me, to help us understanding a 10, then we can make it a 10. But if we want them to help us understanding about ones and 10 parts, tenths, then we can decide now in this setting, it is a 10, it is a 1, it is a 1. And when we divide it in 10 equal parts, each of them becomes a 10 parts or a 10th. Yeah, and it's the decimeter square is the unit 1. The decimeter stick is a 10th.
Mm-hmm.
And the 1 is a 100th. And then we can do it the opposite way and put all these small centimeters on the decimeter square. See, yeah, there is room for 100. If that's necessary for
Isn't that confusing for the children?
To have this flexibility and in that it can be different things.
Because once they can see it's 100,
yes,
and now you make them think it's 1.
Yes, and I understand your concern, really, of course. But my experience is that this is when we work on these concepts and the children really get these concepts, learn these concepts so that they have the possibility to transfer, then they also have this flexibility. So it is not so complicated for them. So we are calculating, and we need something that can be ones, and that can be tenths, and that can be hundreds when we work on the whole numbers. And we need also something that can be ones and 10 parts and 100 parts when we work on the decimal numbers. And to really count up and to demonstrate how that is possible, that will help them, I think, if they don't really get it. Of course, if a child struggles with this, we can't use it. Simple as that. But my experience is that this flexibility follow the knowledge in terms of concepts. Once the children have concepts, then they are not depending on this one aid, but they can use it in a flexible way, which is also one of the points in the teaching, to make them independent and able to transfer, because then they don't need anybody next to them helping them. Then they can do things on their own, and it can become tools for them in their lives. But it's a very relevant question. And I think maybe also why we often see this kind of confusion is that the children hasn't had a possibility to really work on the concepts in a way that has facilitated them to learn it into a level of transfer and flexibility. Transfer and flexibility, they are two sides of the coin, actually, more or less. And what really could be disturbing here was that square with text that shouldn't have been there. I'm sorry for that. We have to take it away. So now we are not, just writing it in another way. But here, what we have here can be written as 1 plus 1/10 plus 1/100 plus 1/1000 as a fraction, but it can also be written like this. And the numbers have different colors here because that can help us to relate them to the different. And of course, just to explain it like I do now, it sounds very complicated, but when the children have learned these concepts, it makes sense for them. And they could actually be able to make this explanation sense and to really be flexible in switching between one and the other. Because a 10, that is something that helps us counting by tens. And 100 is something that can help us to count by hundreds. And the tens part is what we get when we count, when we divide a whole, and we can decide what is the whole. It could be an orange or an apple, or it could be a measure or a number line or a sheet of paper or whatever. If we divide it in 10 equal parts, each of them will be tens. And if we divide it in 100 equal parts, each of them would be 100. And then we are arriving at the decimal numbers. And what is listed in the curriculum is comparing decimal numbers, rounding decimals, decimals on the number line, addition and subtraction of decimal numbers, and multiplication and division of decimal numbers. And we are not going to get into all this, of course. We have half an hour or so again, but this is when comparing decimal numbers, it would be relevant to do something like this, and the school book often do something like this, at least in Norway. And and also the national tests to test the knowledge of the kids would typically use tasks like this. And there is a common misunderstanding here that the number of numbers or digits increase when the number increases. So that's one way of telling that this is the biggest number. And even here it is just 1. Even if you relate to the comma, here is just 1, and here is 99. And 99, of course, is bigger than 1. And I think I told about the method of using meters and centimeters when you teach hundreds, and liters and deciliters when you teach ten parts, without using their kind of mathematic names, the tenths and the hundredths. And I don't think that's a good idea, because it is the name that's relevant, that really, and that is transferable and independent of the context, that really facilitates the concept learning. So it's very important to call these parts by their real names, a name that is related to their part of a whole, and not to whether it is a volume measure or a length measure or whatever it is. So, and when the child has grasped that, it's easy to see that, of course, here are no tenth parts, then this must be the biggest, because here is as much as a 10 parts. The decimals on a number line, I looked up some pictures in internet and found this, and I was just looking for this way of working with the number line and fractions. And what it could be done here is to perceive a fraction as a point on the number line. And it's possible to illustrate something with giving a point on a number line, but a fraction isn't a point, it is a unit. That's my argument, and I'm not sure if I was discussing with a mathematician that it would be an easy discussion, actually, because mathematicians typically have an abstraction level that has taken their thinking away from the concrete thing. And when we work with kids, we have to be in this concrete world where the words we use also is perceivable and understandable. And then in the next go, of course, we can decide that this is something we can also do in this way. But 4.6, is it a spot on the number line? I will say no, actually. Is it a number of tens, or is it a number of tens and ones? And we could slash both, and I think these slashes are arrived as another page because they were disturbing me on another page, actually. But here we can slash these. They are a number of tenths. This, we can think of this as 46 tenths. And we can think of it as a whole and 4 tenths. 4 ones, we can say, according to the way it's listed here. And we can't say it is not a spot on the number line, but it not in the same way as it is a number of tenths and a number of tenths and ones. It is a number of the number line, but it can be illustrated with a point, a spot on the number. Like the numbers also are symbolized in this way. It's important that we illustrate and speak about these things in ways that is helpful. And I think to use the number line with the fractions it's chosen because somebody thinks this makes it easier for children, because they are used to work on the number line. And for some children, I'm sure that's correct. And then we speak about the children who easily learn these things, who easily transfer an abstract on a level that not all in an age, a typical average age group will be, but some of them will. Additional decimal numbers as you can see here, is whole numbers. But it's easy to make them decimal numbers if we decide this to be a 1 instead of a 10, then this must be tens. And then we must do something in the way we note it, and we must write 1.3 instead of 13. And with the other, we must write 1.4 instead of the 14. But the rest of it will be the same. So the numbers, digits will be the same, but their meaning will be different, because we have decided that now this is not a 10 anymore, but it is a 1. And again, we can't just out of nothing arrive at such a way of working. This requires a flexible knowledge in the children that must in a group to make sure that most of the children in the group will really understand and be able to work in such a way. They need to have learned these concepts. So here, again, we have 7 ones. And what happens here is that we take one of the tens originally, when this symbolized tens, and we make 10 ones. And we can subtract. We can take away the number that this calculation requires. And we can do the same here. Now we have 7 wholes and non-tenth part, and we are supposed to take away 2 wholes and 3 tenth parts. And then, of course, we need to take 1 whole, and we need to make 10 tenth parts. And we can do the calculation again in the perfectly same way, but the numbers mean something else. And again, this is just kind of another way of working and using these concrete materials as symbols for another type of units than they did in the previous. And that gives also a kind of a whole picture about the calculation. What we do in these operations is the same. What changes is the units that we are working with. But the methods, the ways of calculation, they are the same. And to my mind, units should be much more in depth taught to children, like it's normal to do when it comes to the ones and the tens and hundreds. I'm sure that's the same in Czech as in Norway, that to work on the concept of tens, that is done with concrete things of different kinds mostly, and the children, it's worked a lot on, and the children will have more or less a concept, at least some knowledge that is transferable. But not so with the tens and the hundreds. They are very, very kind of surface taught to the children, and that causes that the children kind of perceive, and maybe even the teachers perceive, to work with decimal numbers as something totally different. And actually, in the last decades of the previous century and into this century, there were in Sweden a math professor who worked a lot with math difficulties at Örebro University. His name was Olof Magne. He was kind of, in the Nordic countries at least, a kind of an idol when it comes to math problems and maths teaching as a whole. And he carried out some research when a new curriculum was introduced in the Swedish schools, and they had a possibility to use a whole small village or a small city. I'm not sure of the number, but there was quite a number of informants on the different steps, and they examined all the different steps and saw the number of corrects, and actually the details of this, but they gave the children tasks that covered the curriculum as good as possible. And of course, when you implement a new curriculum as a country, as a system, of course, the intention is that it should be easier to learn mathematics and the results should be better. And in three occasions, this happened in Sweden, and the last one was 2004 or something. And they published a report after this study, and what they could see very clearly was that the level was more or less the same. There were no difference, so no gain in changing the curriculum actually. And what they saw was that when those students that had math problems and problem that was demonstrated, that was in the 5th, 6th grade, at this age that we are speaking about now. And that was very, very clear results in their study. And they didn't actually relate it to decimal numbers and fractions and percentages, to the kind of the change from working with whole numbers to parts of wholes. But I think that was the point actually in their findings, that we don't teach these units in the same deliberate and in-depth way as we do with whole numbers. And that it does not give the children and the adolescents same possibility to go into depth in their learning. And a lot of those who struggle with this type of abstraction and just to work with the numbers without having any reality to connect them to, they will kind of lose in the system. So I think we really have something to gain to make more people succeed in mathematics. In Norway, we have a problem because there has been prejudice towards math teachers. And there has, for a long period, there were no requirements for students who started, or those who started teacher studies to become a teacher, teacher training to become a teacher. And then the previous government, they implemented demands of having the marks of 4 in a scale that's from 0 to 6. And a teacher student could not start unless they had a mark of 4 in mathematics. Please, just a moment. Yeah, I got a message. Excuse me, excuse me, Celia. The point is, this teacher students with 3 from the upper secondary school, well, they wouldn't be admitted to start teacher training. And obviously, a lot of good teachers get lost in such a regime, because a lot of these students, they would be very good teachers, but maybe not so good in math, or maybe they could be good teachers in math as well, just because they have experienced problems themselves. That can also be a good competence to bring as a teacher. That's really, everything wasn't easy peasy for me. And then I can understand my students who struggle as well. And actually, I would say if the system requires something like that, system should be responsible to teach all these students to manage and to get the marks that's necessary to get into the teacher training. Now, you can recognize it, but I think this is important. And I think we have the possibility in our systems, both in, at least in Norway, that's what I can tell about, but maybe also in Czech, to facilitate better this work for the kids. And it's very good to hear that you work on this from the kindergarten. That's great. Well, we don't need to take these examples because the system is the same. Here, the ways we calculate are exactly the same, but the units are different. And the little comma, it does nothing else than telling us that's the unit. Tells us about now it is a different unit, but and which unit, but nothing else. In all other ways, it is the same. Yeah. You know, let's look at just the ways of writing it here. Or maybe no, I'm going to demonstrate that. Because once, and actually that must be more than 20 years ago, or about like 22, 23 years ago, a colleague of mine, she called me and she said, Gunvor, I know you're interested in math teaching. So now I need some help. Because we were calculating like this. 10 divides with 18. And then you say, and excuse me for all these numbers, I try to make what is it called? Some things with the presentation so that those numbers should be covered now. But 10, let's pretend they are, or let's just explain in order. 10 divided in 18, that's not possible. There is not a whole a one for each. So then we must write nil here. And then we have used nothing. And we have still the 10, but then we can add another nil. And then we can calculate, and we can say 100 divided with 18, that's 5. But we put on a comma here. And actually why we do it, we're not explaining that well enough to kids, but when we do it, we transfer the next numbers and make them tens and hundreds. And that is important to maybe not just explain for kids, but to teach in a ways that they really understand it. That's how it is. That's what we do. But when we don't, and that's not usually done actually in Norwegian practice. But this girl managed the student of my colleague managed to do this calculation. So, and then the next thing is, okay, 5 times 18 equals 90. And then again, we have a leftover of 10, and we can add another nil, and we can continue the calculation, and we can let it go endless if we want to, but we won't want to spend the time on that now. But then the child asked, hey, where does all those nils come from? Like here, we just add a nil here, and we add a nil here. Doesn't make sense. Or does it? It doesn't make sense if we do it with concrete materials, because then we can demonstrate how we have 10 ones. That doesn't give one whole one for each. But when we make 10th part of them, then we get 100 10th parts, we have 10 holes. And then we can divide 10th parts. And that will make 5/10 parts to each. And when we have given each of them 5/10 parts, then 5 times 18, we have used 90 of them. And we have 10 tenth parts left. And well, we can say, we can use that as a what is it called, with division with leftover. There is a word for that. I don't remember that word now, but you will understand what I mean. And we can say we have 10 left. But maybe we want to go a little bit further and say, okay, we had 100 tenth parts. Okay, we have 10 parts again, and we can divide each of those in 10 parts, and then we get hundreds. And we get 100 of them, and we can continue. But then this number is about hundreds. And if the children has learned really in depth these units, initially, this will be obvious to them. But we should be more outspoken in what is it that we do when we just add these nils. That's how I have learned this. Then we add a nil, but of course the decimal comma is necessary to add them. But that doesn't necessarily in itself either make a point for a child. So this in-depth knowledge is necessary. And what we do when we add these nils is we transfer from one unit to another in the decimal system, or yeah, in the decimal system when we speak about these numbers. Yeah, not necessary to do it again, actually. And then the fractions. And again, meaning that there's something else in the background. But you can see these pictures, and I can speak about fractions. When we introduce fractions for the kids, very often it's introduced like this, with a fraction with more than one part. So the fraction with the number of counters and names are what we introduce for the children. And in that way, we let the children work with and calculate with the fractions without relating to the units that the actual type of fractions actually is. So maybe it's a good idea. Now my computer works slowly. Like this, here we can see different fraction units, and both those pictures I found in the internet when I prepared for this webinar, and of course this must be there must be added other activities with the different units here, but at least a picture like this shows us different possibilities for units when we speak about fractions. And to my mind, it is a point that the children learn also to work with, of course, they need little by little to learn all these rules about how you calculate the fractions. But it is a good point also to teach them fractions as a unit. And then we need 1/2, 1/3, 1/4, 1/5, and so on and so forth. And of course, quite a few of these, as we mentioned earlier, is possible and easy to really do in the real life. When you have, I don't know the English term, passa, this device that we use for geometry, when you're going to draw circles and do different things with the circles and the lines and so on. Can help us. with this. But just to remind ourselves that units are something also when we work with fractions. Would you like to also take this small story about telling the time in the end? Yeah. So this picture is not the boy, and his name is not Chris either, but he came to me when he was 11, and this is many years ago. He's a grown-up now. And he had math problems, and he also had general learning problems. And his grandfather was a psychologist, and he wanted us to work with him with the concept teaching model, and that was why he came to us and asked if we could work with him. When you work with one child, I think it's important to get their motivation and to work from their motivation, their point of what they think is important to learn. But I never reached asking the question, what's important to learn? What do you think? Because he sat down on the chair and he said, I want to learn how to tell the time. And he had a 2 years younger brother who already knew how to tell the time. And it's embarrassing when you don't know the same things as your younger brother do. So he wanted to learn that. And so this looks a little bit not tidy. I actually haven't tried the animation of these pictures. Excuse me for that. But to tell the time, there is also some knowledge and some skills. Knowledge to get the big picture about time, skills to be able to calculate with time, to be able to read a clock phase, and also to read digital numbers and so on. But concepts, there must be knowledge in terms of concepts about time units, like seconds and minutes and hours and days and nights. And do you have in Czech language one word for day and night together?
Well, it's the same. Well, we say den, which means day.
Yeah.
Okay. But we use the same word for the period when it's light outside. Okay. Okay. Yeah. And then we have another word for night, which is knots. Den a noc equals den, 24 hours. Yeah, yeah. So dens can be used both about daylight and also about day and night. Mm-hmm. Yeah. In Norway we have the word day, a dag, night, natt, and 24 hours we call døgn. Oh, so that's clever. Just to distinguish. Yeah. Yeah, it's interesting. But for us, that's normal, you know. So it's a surprise when we arrive and really discover that that's not common in all languages. But that means that also this is a time unit in our language. Mm-hmm. And then we need a concept also about time points. Now the time is exactly, and so on. And we need to relate it to the clock phase, and we need to also understand changes in the clock phase and the clock hands position. We need also to relate to changes in light, day and night, season through the year, and so on. And to also a pattern in this. So pattern is also a relevant concept, actually. And when it comes to the clock and the clock pace, with a digital analog clock, I mean, shapes, like round shape and straight line shape, and numbers, holds and parts of holds, positions, directions, and also a lot of skills we need to do. And we also work on flexibility with tasks like this. Who has a figure with triangle shape in color? And of course, the one who has it, it's not enough to just point and say, I have it. Okay, tell me what you have. And that was difficult for him to say it has a triangle shape and green color. He was exhausted. And when he had learned these concepts and also worked with such type of processes, that kind of directing your attention to the different features,
he could do these other tasks and this other game very easily, and he could recognize when the instruction was who has, number 4, straight line shapes, red color, sloping position, which is much more complicated. So this flexibility and facilitated with this type of analytic coding, you can call it, flexibility training, it has been amazing to see that. And a lot of time also relates to the seasons of the year, of course. When it comes to the seasons, one after the other, the days one after the others, and the different times of the days one after the other, we have this succession of units or names of each units. And we have also time units like these natural ones. And also we have some cultural time units that somebody has invented once upon a time, and it will be interesting to say something about that as well. But we can also speak about time units as long as it takes to watch children's corner at TV, or as long as it takes these days probably more to play this and this game on your computer or your iPad, or as long as it takes to say your name or whatever, that you can do and easily perceive how long time it takes. So a lot of concepts like this. And also it would be possible to do it like along a number line. But then we must have to turn it back for every day. They were really clever, those who invented it possible to do this in a round shape. And also to establish the mechanics that made that possible. And then we can count all these 12 hours from midnight to midday, from midday to midnight. And we can write numbers for each hour, and we can give a clock hand to go around and tell us about which hour is it exactly now. And we can also count in minutes, and that's also another genius things about the clocks. We can count, we can divide it in 60, and we can put clock minute hand on that really takes 1 and 1 minutes all around the clock face in an hour, the 60 minutes in an hour. And why not call them hour hand, minute hand, instead of big hand and small hand, or long hand and short hand, or whatever is normal in the different languages. It's most easy to start with the whole times and look at all these clock faces that show whole time, and the time hand, the hour hand tells us about how many hours has passed since midnight or midday. So I do this a little bit quick now because I am asked to give a telephone call at 2 minutes after in 1 minute actually.
Okay.
The point of the clock hand showing half an hour. And how are these two similar? So the concept also in reading a clock hand. Mm-hmm. And this boy was perfectly able to do the time after the session. And it was a lesson for me that time to see how all these concepts really helped him to tie this to his perception of day and night, the darkness, the light, the seasons, and so on. And I've seen it later as well. So that